I working with H1 Today's topic is matrix, which is second chapter of 12th science. Now, in this matrix, the subtopic is inverse of matrix by using adjoint. Before start to find the inverse of matrix by adjoint method, we must know the adjoint of matrix. For adjoint of matrix, we must know minus and cofactors. How to find minus and cofactors of the element of the given matrix? For that, the matrix must be a square matrix. Now, suppose consider the matrix A, which is square. Now, in square matrix, it may have order 2 by 2 or order 3 by 2. For simple example, for the basic understanding, we consider here the matrix of order 2 by 2. Now, the elements of matrix A are A11, A12, A21, A22. So these numbers 1, 1, 1, 2, 2, 1, 2, 2. These represent the elements in number of rows and number of columns. Now 1, 1 is the element in first row, first column. A12 means a number or the element in first row, second column. A21 similarly second row, first column. Now this is the square matrix. Now in a square matrix, we have to find first minus and cofactors. Now minus and cofactors are of the elements of the matrix. Now first find the minus. How to find the minus? Now suppose as it is minus, so minus of element, first element A11 is denoted by M11. So M11 represent minor of element which is in first row, first column. Okay. Now, so M11, to find M11 for the element A11, so we have to leave the elements in rows and in columns of the element A11. So M11 is left first row and first column. First row, first column elements left row. Now take the determinant of the remaining. Now the remaining element is only A22. So this is the minor of element A11. Now similarly find the minor of element A12. For this we have to left the first row and second column. So A12 for this minor of for this element we have to left the element in first row and in second column. So therefore, take the determinant of remaining elements. Now only the remaining element is A21. So this is minus of second element. In this way, find the all minus of all elements. So second element is over. Now third element is M21. Now M21 left second row, first column. So therefore the remaining element is A12. Next M22, so we have left second row, second column, second row, second column left. So therefore the only remaining element is A1. So this is the way to find the minus of the elements. So this is for 2 by 2. In next video we learn the minus of 3 by 3 matrix. Now, so these are the minus of the elements of square matrix having order 2 by 2. Now find the cofactors. For cofactors, it is a simple formula. So Cij, which is equal to minus 1 to the power I plus j into Mij. So this is the formula we have to remember for finding the cofactors of the elements. Now, by using this formula, in general, in books, cofactors are written as A. Now, for better understanding, as it is cofactors, we represent here C. Okay, do not confuse. In books, cofactors are denoted by A11 or Aij. But for the better understanding, we are denoting here Cij. C is cofactor. Now find the cofactor of first element. First element is the element A11, which is in first row, first column. So by using this formula, so therefore cofactor is minus 1 to the power 1 plus 1 Ij, 1 plus 1 into M11. So minus 1 to the power 2 plus. So M11 की value आपके पास already है. Okay. So this is the cofactor of first element. Next, second formula, C12 minus 1 to the power 1 plus 2 into M12. So remove this because these are the values of determinant. So we write in the next step. So C21 to minus 1 to the power 2 plus 1 M21. Now C22 minus 1 to the power 2 plus 2 into M. So in this way, find the cofactors of all elements of square matrix A. So these are the minus and these are the cofactors. Now after getting the minus and cofactors, now we have to find the adjoint of matrix. Now adjoint of matrix, for finding the adjoint of matrix, we must first find matrix of cofactors. Now matrix of cofactors is denoted by C. Now and this is equal to the matrix of cofactors. Now we have to convert these cofactors into matrix. Now in the same manner which are written in this way. Now C11 means either C11, C12, C21 and C22. So in this way we get the matrix of cofactors. Now here we are denoting matrix of cofactors by C. Now after getting the matrix of cofactors, now we go towards the adjoint. For adjoint A, means adjoint of given matrix A is nothing but it is the transpose of matrix of cofactors. Now अब यहाँ पे आप वर्ड में भी लिख सकते हो transpose of matrix of cofactors. Now transpose of matrix of cofactors is C transpose. C transpose means we have to convert the matrix of cofactors into transpose, means we are changing the rows into columns or vice versa, columns into rows. Now here, so this is your first row, so convert the first row into first column C12 and second row into second column C21, C22. So this is your C transpose. In this way, we get the adjoint of. After getting the adjoint A, then use the formula to find the inverse, and the formula is inverse. We can write here inverse of A. Inverse of A is matrix A. We can write here matrix A, and inverse is denoted by it is denoted by A inverse, and it is formula adjoint A divided by determinant of A. Now again you can write in this also 1 upon determinant A into adjoint A. So this is the formula to find the inverse of matrix, given matrix, by using adjoint A. So this is for 2 by 3. For the second example, we consider the matrix 3 by 3, but it is better to solve the examples of 3 by 3. So this is the basic information to find the inverse of matrix by using adjoint A. Again, please remember one thing. If the determinant A is equal to 0, then the inverse of matrix does not exist. We know better because for dividing any element to 0, it gives infinity. Hence, so we cannot divide it by 0. Hence, if the determinant of A is 0, then inverse of the matrix does not exist. Thank you. We see the examples.